So what is the intuition? So there are 10 people. Like if you end up with 2 people who don't know anyone, and both of them don't know anyone, then it's fine. Then that's then that is good. Huh? There are 10 people, and you have to show that there are at least 2 who have the same number of friends. This is actually can be taken up to the level of a theorem later. So the boxes will be like number of acquaintances. If you show that 2 people fall into the same, so there are not enough possibilities for number of acquaintances maybe, and there are 10 people. Let's think. So any ideas? Okay, so here is a question. What are the possibilities for the number of acquaintances? What can the number of acquaintances be? Uh, 10. Is 10 a possibility? Yeah. So that's a more accurate answer. 0 to 9. Oh, the most difficult thing is to spell this thing. Probably still wrong. Anyways, number of acquaintances. So it can be 0 to 9. So it will be important that I this. Now think about it. If someone has 0 friends, then what does it mean? And more than this, how would you maybe model this? How would you picture this situation? So that can help you to think more clearly. But there are 10 boxes. Yes. But your idea is in the right direction. We have to make this 10 boxes into 9 boxes somehow. As of now, there are 10 boxes and there are 10 people. So let me write that way. Can build on that. There are 10 boxes, but we also have 10 people. Think freely. So you don't have to think, okay, how to apply this principle. But you can just think freely also and see. It can come through other ways, actually. It just has to be correct mathematically, logically correct. That's all. So what are you guys thinking? I just want to know, because then I can try to build on that direction. No, it is possible. Right? It's possible that someone has zero friends. I mean, yes, let's say some stranger walks into. Mathematically, it's possible. So, but we can use this because this looks like a strange situation. Yeah, it feels like a strange situation. So let's use it to divide the problem. Okay. If you find a strange situation, and this is not something with just you would feel this always, you find something, some strange situation in a problem, you can use that to divide the problem into two cases. Right? So let's use it. So having zero friends seems strange. So let's use that to divide the problem. Okay. So if everyone has at least one friend, that's the one case, right? If everyone has, maybe I'll just say we have two cases. And this I'm breaking based on so Aparna's observation that zero friend seems a little strange. At least, yeah, it's logically correct, but it seems strange. So someone, let's say just this is the P1 itself, right? Doesn't matter. P1 has zero friends. And the second case is everyone has at least one friend. So what should be the next step? What should be the way forward? Then we are done. Yeah. So this case is done. So the art of breaking up a problem into cases is very important. You have to get a sense. There is no theorem for that, but you have to get a sense. When do you have to break the problem? How do you have to break? There can be several ways. Like if you find that, assuming something makes the problem done, then you don't assume that and you take that other case. Or if you find something odd, then you use that, take some exception, use that to divide. You have to think, but you have to be bold, divide, and move forward into the simpler problems. That's when you become a more aggressive problem solver, means just moving forward and going back. Okay. Yes. So in that case, the possibilities for acquaintances are from 1 to 9, right? Possible number of acquaintances. And then, as you said, there are 10 people and 9 boxes there. Something. Yeah? Because now there are 10 people, and the number of yes. Yeah, but in this box and this language, you see so many things come into this language. That's the beauty of it, right? They come into this simple framework, but just breaking it into this framework is the yeah. So this is like mathematical modeling for mathematical problems. So these are not mathematical, me, but it is very, very, very interesting that so many things can be brought into this framework. Yeah. So then we are done. Any questions about that, anyone? So now let me just look at the zero friends case. So now let's focus all our attention on P1 having zero friends. So P1 has zero friends. So I'm putting P1 here. So that's putting it there means zero friends. Now what can we say? P1 has no friends. In this case also we need to show that there are only 9 possibilities. Right? And then only we can say that two things are going in the same place. Yes, perfect, right? Yeah. The nine possibility is not possible, right? Because P1 refuses to know anyone, it doesn't know anyone, right? So how can someone then know everyone, right? So this implies that nine friends is not possible, right? As no one has nine friends. Wonderful. This is so you can think, right? It is such a nice technique. That is the beauty of it. Yeah. How you guys find this interesting? I suppose I don't need to say anything. This is interesting. This is There is a straightforward statement in some sense. If you draw the small cases, you see, yeah, but then to prove it, the right language is important. Otherwise, it becomes a mess. It becomes casework and so on. I will talk more about this if when needed, but since we did not need to do anything else like drawing a graph and such, so I did not going into that. Okay. I want you guys to take it as drive it as much as you can. That will be, I think, important. That is important. So I'm not saying anything about that. If you guys have questions, you can ask like something like three people have same number of condenses, what conditions you can then you can think. So we did one problem of number theoretic nature. Uh, one problem we did, which was maybe you could say purely combinatorial. All of this is combinatorial. This is something which is. And let's do a third one, which is slightly geometric in nature. Yeah, I think it's good to have a balance. Um, yeah, so we are learning the techniques and also ideas. So let's go. So let's have a third. So we have an equilateral triangle. Let's see. So we don't need it to be equilateral, but let's just take equilateral triangle of this mouse is versus side length 2. Pick 5 points inside the triangle. Pick any 5 points. Or you hit 5 whatever dots. Pick any 5 points. So I'm framing them like this. Pick any 5 points. We want to say, show that at least two of them will be less than 1 apart. I'm just saying 1 and 2. I'm not saying units. Because you don't have to do any actual measurements. It's maths. That's that. So that is the question. Obviously, 5 points are taking inside the triangle. You could say on the edge also. But no, I have to pick it inside actually. And this side I'll come with irritation. So, So this is again similar nature. We want to say that we don't have enough space somehow. That's what we want to somehow say. Somehow, yeah. So yeah, we don't have enough number of acquaintances. We don't have enough consecutive pairs. Something one consecutive. This is the type of principle that you can keep doing maths. The more maths you do, you will be applying this principle in subtle ways in any place it can come. Whether you're doing MSc, PhD, it will just keep coming up. Principle. Obviously in more, obviously, but at the heart of it, it will be this principle will be there. And without this, sometimes it becomes simple things become complicated. I've even seen some experts quote this by Pigeonhole Principle. This happens. So they could have still said it, but they just to be sure they leave it on the principle. Sometimes it's in a strange situation that problems. Just we declare it through that. Yeah. No, but one apart and two apart. What about 1.5 apart? How do you, are you accommodating for that? Because you did say like less than one apart, so that part is okay. But you need to then maybe something. Right? So we have to divide. We have to divide the points. Let's see. Yeah, okay, if you want to say that, no, but it doesn't make sense, right? One apart from what? Right? So you're saying pairs of points, right? Okay, so, okay, then we will have 10 pairs from 5 points. Okay, 5 choose 2. Oh, you can see that instead. Okay, so partition, maybe I can say partition the, not points. So you're not partitioning the points, right? You're partitioning pairs of points. So maybe let me just draw the picture. So this will be, this box stands for, but there is a, okay, let's see. So there are pairs of points which are, yeah, but it doesn't lead to a partition, right? That is the problem. Like if you say pairs of points which are less than one apart, or then, so if you have points in the triangle, and if you have boxes like this which are equal to one apart, 2 points which are equal to one apart, you're going to put in the second box. 2 points which are more than one apart, you're going to put them in the third box. But you see, then 1 point can go to several boxes, right? That is the problem, because if you, let's say you have a triangle, pick some things like this, 1, A, B, C, right? A and B can go, let's say that this is less than 1, right? So A and B will go to the first box or not. If they go to the first box, but then C, I mean, I don't know, C is more than 1, right? So C goes, but then with respect to A, it goes. So it's not very clear what is happening. I mean, it can be made, but then it will be more complicated. You see the point? Yeah. One can make this that okay, I'm not going to take point, but pairs a point, but then it will not make complicated. Not understand. No, and it's not necessary to do the problem. Probably not even useful. This time we have to create actual space issues in the sense that we have to actually partition the figure. That's the that is the easiest way. Not create these combinatorial boxes. Boxes will be there at the end of the day, but they will be actual parts in the triangle. So the key is to partition, maybe I can say this. Partition the triangle. Into how many parts should we partition the triangle? Three parts. Okay. So if you want to partition it into three parts, then how do you do that? Or why? Why three parts? Mm-hmm. Mm-hmm. Right. Right. So you are again, yeah. So this is again like you're kind of going to extreme case, but it's still a case, kind of. But yeah, it tells you that this is true. But okay, but even from here, how do you say that there will be when you put two more than two of them will be less than? Mm-hmm. So you're saying even with 4 points you can do it? No, no, that's not correct. But that is not correct because see, if I make a circle of radius 1 and then another circle of radius 1 and then another one of radius 1, this is not going to solve the problem, but I'm just to answer you. You see, this is the thing. You see, you can pick the fourth one in this. So the first one is, let's say at the vertex, doesn't matter. Let's not go into the logical issue. One of them you can pick anywhere inside that region, and that's more than one apart from all three. Yeah. Um, no, no, no. That is okay. So to but then you see, even then in this situation also, right? It is more than one, but it is way more than one apart. Yeah, someone is saying yes. It is way more than one apart, right? Because this itself is one. So what is one here? Yeah, this is one, almost one. So this is, it's more than one. It's root 3 by 2, something like that. So yeah, so this I'm picking 3 points very close to the thing and one in the center, very center. Then it is 4 is not enough. But the fifth one you can see you cannot pick. Yeah, that is the but how do you explain that more clear? So you do need 5 points. So I mean that's the point is that you cannot do with 4 points. I mean in the sense that, or rather I should say you can. With 4 points, you can place them so that they spread out. Okay. But how do you say that 5 points will you have 5 points in two of them? Uh, right. The fifth, so everybody sees that, right? The fifth point I cannot put inside. So then you will say that I'll put the fifth point, so this is point 1, point 2, point 3, point 4. But then the fifth point, if you're going to put inside this, then what's the guarantee? How do you then show that it will be less than? Why? Okay. Yes, but you have to say it more rigorously. Close together. Yeah. So you have to say that any 2 points in this final region are less than one apart. Is that right with everyone? Yeah. You have to show that in this final region, and this is still our proof is wrong in some sense, but as we are going, it is slightly incomplete, but can be made complete. We have to, but I mean, but even if you follow up from here, that 3 points are picked close to the vertices, now 2 points you're going to have to pick inside this, because otherwise you're done. So these 2 points that you pick inside this blue, anywhere, so it's not has to be, you have to show that any 2 points you pick inside this have to be less than one apart. Is that, but that's not clear. You see the point, right? I mean, if you place the fourth one, so I was slightly wrong there. I was thinking this would work. If you pick the fourth one here, then it's fine. Is that right? If I pick the fourth one here, then any fifth one I pick, it will be inside this blue region. So let me write this. Okay, if 1, 2, 3, 4 are as drawn, then show. So someone argue this for me. Show that the fifth one has to be less than 1 apart. So that fifth point so how do you really show that? So the fifth point is going to be in the blue region, but you have to show that it is less than 1 apart from 4. That's the natural choice. So how do you argue that? Well, it's simple. You say, I'll take the circle. The circle, you can tell them what's the radius of the circle. What's the radius of the circle? Less than 1. Right? The radius of that last circle I've drawn is less than 1. That you can check. It is something. Root 2 times root 3 by 1/3 of root 3 by 3, something like that. You can it's less than 1. Okay. That radius is less than 1, and you can calculate it. This is the you can use Pythagoras and so on. Yes, because you are in the circle. The circle is the right way to say it, right? Because you are in the circle, and one point already there at the center, that is also important. Fourth point is at the center is important. Then the fifth point you cannot pick in any way. In any way you pick it, it will be less than 1. In fact, anything you pick in that circle will be less than 1 distance point. So how is our proof incomplete then? Well, our proof is incomplete because we are making an assumption. We are saying that the first 4 points are picked like this. It seems good to pick the first 4 points like this to maximize the distance, and then show that even then you are failing. But that doesn't say that there is no other way, no other smart and strange way to arrange the 5 points. Is that right? There could still be a smart arrangement of 5 points. So it seems unlikely, but yeah. The proof is not complete. This is probably the most important thing. Do you guys understand this? That the proof is not complete. So it is similar to like in the consecutive question, if you say that if I pick 1, then I cannot pick 2. Then I'll pick 3, but then I cannot pick 4. Then you say then I'll pick 5, but I cannot pick 6. For instance, I can only pick 40 numbers. Then you say you are done, but it's wrong in that sense, right? Though it kind of seems correct because you're applying kind of a greedy method and showing it's not possible. So, but that's wrong. So it has to do with some interesting things like what you pick is like a maximal set. You cannot expand that set. For example, given these 4 points, you cannot put a 5th point on top of these 4 points. In addition to these 4 points, that is clear. That's what you just saw. But still, the proof is not complete. You have to show that there is no other way. There's no way. So how do we complete it? So this picture is not good. This picture will not help you because you see in this picture you can say that there are 4 parts, right? So I have to partition my triangle into 4 parts because then I will say that 2 of them are in the same part, and then I can somehow resolve. Okay. But this picture is not good, maybe. So we'll have to see, or maybe it is good. We'll have to see. In this picture, if there are 4 parts, so in this picture there are 4 parts, right? How do I show from here? Well, just use just the usual again space kind of thing, right? That there will be 2 points in the same part, in the same region. Okay. Let me say we have region A. We pick 5 points. So 2 of them will be picked in the same region, right? B, C, D. So this partition came up naturally, kind of, in telling, I think, telling to Shana, in the sense that what she said, like that. But the point here is that this just came out. This was not the thing I was thinking initially. There is another construction, but let's see if this one also works. Yeah. So there is this way to partition. Now the point is that when you pick 5 points, okay, pick 5 points, yeah. So at least 2 will be in the same region. Then right, that is clear. But then will those two be less than 1 apart? That's what we have to show, right? So how do we say this, or can we say this? Be less than 1 apart. And so the answer is yes if they are in A, B, or C. Then the answer is clearly yes. Is that not? Is it correct? Does everybody agree with that? Does everybody agree with that? If there are 2 points in A, then they are less than 1 apart. If pick any 2 points in A, then they are less than 1 distance apart. Is that correct? Or do you think there is some flaw? There can be. So be careful here. So let's try to give some reasons. No, maximum distance is not always the radius. Think. I mean, in this case, it may work, but you have to give some more. Maximum distance is not always the radius. I mean, the diameter is there, right? But in this case, that's not available. But you have to be more careful by saying that. Or is it even correct? So, is it correct, everybody? If this is just a, if I'm picking 2 points in that, 1/6 circle, I mean, this is 60 degrees. That's important, I suppose, here. Then if I pick 2 points, those red points are marked. Are they, I mean, any 2 points, are they going to be distance less than 1 apart? We have a quarter circle, or not a, sorry, in a quarter circle, that's not true. Right? Yes, side length is 1, or yeah, less than, it's equal to 1. But this is not a triangle. So if this was a triangle, then it was clear. Yeah. If this, so instead of this picture, if I were to draw a triangle, I mean, if I have drawn the most natural partition into 4 parts, I have to divide it into 4 parts. That is clear now. And then the most natural one, instead of this headache type, this is like inconvenient to reason, right? Though it's possible, obviously, to reason whether it's possible or not. But the most obvious, you can just divide it into 4 equal parts. You know how to do that. Then the answer is very trivial. Then the answer is trivial because the same reasoning will work for all 4 parts, and you can just show it. Let's take any 2 points. It is less than. I mean, still you have to do some work, but you can show it. How do you show it in the case of a quarter circle? That's the question. Oh, sorry, in this circular region, 1/6. Because there is a slight, that's that kind of thing. And even in a triangle, how do you reason it? That if you have any 2 points, then they are less than 1. So you have an equilateral triangle of side length 1. You want to show that if you have any 2 points and they are at a distance less than 1 apart. So these two things you have to think. One of them is certainly correct. One of them you have to think. So, Aparna, you can say first. Yes, it should be, but you have to still prove it. It's not yet a proof. Right. You see, it's not a proof. Prove it. I can understand it is correct, but not prove it. So you have to fill that out. So Ishana, you were saying something? Mm-hmm. Mm-hmm. No, no, but there is a subtle issue there. No, that's not correct. So you're not using, for example, the fact that it's 60 degrees, right? So, but your reasoning will not go through if it's a quarter circle. You see, it doesn't work. But I mean, it's correct, but you have to, because you see, the problem is that if you take 2 points like this, you want to show that this distance less than 1 apart. So maybe you can, I don't know, you can take this, you can translate it to something here, then you can say that it's kind of less than, but you have to do some reasoning. Then it will reduce to this other construction, right? Or is it something? But yeah. No, no. Okay, then it will become a triangle. But then the thing is that the whole picture is not a triangle; it's a circular thing. Right? It's a little annoying, but yeah, it is. It is true. I don't. You have to see. Okay, just check it out. Check it if it is true. Try to find, because this kind of reasonings are also important. So you have to apply some sort of a triangle inequality, maybe. Okay, so you have to see. But the 60 degrees, I suppose, will be important. Otherwise, this doesn't hold, as you can say. So, but I suppose we have understood the idea. So filling this gap, they left us like this. So you guys can fill it up. And this is where we'll stop today. Yeah, so maybe I can share this thing with you guys. So Bruality, certainly there you can start trying out the problems from there. So what I'm saying is that you do not, so the Pigeonhole Principle chapter is there. You can read the chapter also, it's very good to read, and there are so many interesting principles there, types. But what I want you guys to do, at least, that you should do the first 5 problems. So there will be exercises, not problems, I think we have exercises. First 5 exercises you should do at least. First 5 only I'm asking. Okay, at least. You should do more, you can, but do that. That is more important than reading the chapter. You should read the chapter also if you can. So yes, that's the thing. And the other thing is that there's another source which is very good, I suppose, in the sense that it actually gets more quickly to the problem solving thing rather than so Brualdi kind of focuses more on theorems and okay, now we have this result and we have this generalization and this that. But there's this book, you guys must know this, Problem Solving Strategies by Arthur Angel. So this is a wonderful book, obviously. Problem is it's a little hard. Okay, so it's a little mature. But there is something special in this chapter. That's why I'm doing this. It's called box principle. It is special in the sense that you see there are the first few problems from problem 1 to 12. Okay, this book you guys will be using if you're not using now, you will be using it later for more advanced practice. Okay, for now you can use it. It's very good if you want. But why I'm suggesting is that the first 12 things you see, they are not problems. They're just like warm up. They don't even care to explain anything like this. They don't have any solutions for this first 12 or any explanation. These are just simple problems. Solution. Okay. So you can try this. You should try this. They're very straightforward in the sense that not straightforward. They're triable. After this, a chapter begins, which I'm not asking you guys to do. You can do it. So yeah, this is what this you can also do. So first 5 problems of duality and try this. These are called the box principle chapter. It is. Usually I don't suggest this book, but here I'm suggesting because I find this. So if there are no questions, then we'll stop. If there are any questions, then please ask me. Okay, then we should meet next time. Try as many problems. At least this chapter you should try, because problems are understandable and they are puzzles and stuff. Okay then.